So in this webinar we're going to be looking at what they call the Civil3D product tools for 2013. They did a similar thing last year and bundled a lot of the Civil3D tools together into one entry in the subscription center, just to make things a little bit easier to find and get into. So let's have a quick look at where you go to find that. So you log into the Autodesk Subscription Center, which is subscription.autodesk.com. Now, by default, anybody or the person that has been nominated as your Autodesk Contract Manager or your Autodesk Software Coordinator, means the same thing, will be the only person that has access to the Subscription Center initially, but they can give access to anybody else that is in the company, so go talk to them if you're needing access into here yourself. Navigate to the product enhancements that you can see here. Product enhancements. There we go. On the left. And this is the one we're after. 2013 productivity tools. Now previously they were all separated out into individual items, which made this list of things you can get from the subscription center quite big. And of course you can see, well, I can see all the other products here, a lot of the other products from Autodesk. If you've got multiple products on your business, you'll see all of those as well. So it could get quite a complicated list. So we're just looking for one, productivity tools for AutoCAD Civil3D 2013. So once you find that, you click on that. It'll take you through to this page, which is the productivity tools 2013. And this is all of them in a big list. Some of them are for specific countries. That's Dutch, that's French, that's Russia, that's Spain. But the ones we're looking at are mostly near the top of the list, I think, which are the ones that most people in Australia and New Zealand are interested in. So that's what we're going to look at on this session. So those are just download from there. Each one, some of them have a data set that goes with it just to play around with, and we'll be using those where they are applicable for this webinar. They've also got a README usually, which tells you how to install it and often how the tool is supposed to work. So we're going to look at a number of them. Corridor Solids utility, the Borehole utility, what they call Cartogramma, which is new. Corridor Solids was available in 2012 or late 2012 version. Borehole utility and Cartogramma is new. The Civil View extension is new. The 12D and Genio ImportExport. Well, the Genio ImportExport was there before. The 12D has had the export added onto it for 2013. Alright, so the thing is to go and have a look at these things. So let's go and find my Civil3D and bring it up on screen. Okay, so the first thing, well, let's start off with the less flash ones, shall we say, first, and move on to the flash ones after that. So start just with looking at the 12D and the Genio ImportExport. Now, once you load them up, they appear in the toolbox, which is this button up here in the ribbon. If you don't know where it is, you click on that, and this is your toolbox tab. It goes into Subscription Center Extension Manager, and you've got all of them listed here. So let's have a look at the 12D one first. It's import and export. Let's just go and bring in a 12D file. Now this extension is going to be expanded on and talked through a lot more by Sean Toomey. It was supposed to happen a couple of weeks ago, but it had to be cancelled at that stage. I think he's got it rescheduled for next Friday, so that would be one if you're interested in looking at this. We're just going to go through the basics here, a very quick look at all of these extensions, just for a matter of the time we've got available. But I think Sean was the driving, Sean Toomey in Sydney was the driving force behind getting this actual 12D importer and exporter built into Civil3D in the first place. So he will explain what the thinking was and what the ways that you can use it with 12D and Civil3D to work interoperably the way it's designed to work. So tune in for that if you're interested in hearing more. However, let's have a look at, we'll just go and open a 12D file. It's just one I've got here, a test file. You open it up and it tells you all the things that can read out of that 12DA file, which is a text file if people haven't seen those before. You can actually right-click in this area here, or actually if you don't do that, you can actually go and tick on and off the bits that you want to bring in, or you can just right-click in this area here and go select all models and strings. That'll bring through as much as it possibly can. So you can see we've got corridor elements, we've got 2 strings and 8 alignments. You've got another tab up here which are the import options. We're going to make layers out with the various strings it's getting from 12D, which is a good thing to do, or you can just use a model name with a prefix suffix for your strings or your layers. I'm going to leave it set like that because that's probably seems to be a logical way when I've used it before. You've got different ways you can tell it what to prefix and suffix various labels with and how it labels things, which is fine. We don't have any points in this one, so we don't need any point label styles. We're going to use break lines to create our surfaces, which is good, rather than using just the points. You can select a surface style you want to put it on. I'm going to have mine on just a triangulation style for the surfaces that come in, and some surface naming options for the prefix and suffixes for the models, etc. It's going to make some alignments. You can choose what alignment style and what labels you want to put on those, what spiral type you're going to use if there's going to be spirals in there, and it's going to draw some profiles, just what you want as your how you want your profiles to come through. Alright, once you've set all that stuff how you want it, you just click the import button. Take a few seconds. You can see it's adding the information down the bottom here. Okay, that's all our strings imported, and we can close this. And you can see this is what it's actually brought through to Civil3D. Okay, so it actually brings through, and then, or you can see my alignments here as Civil3D alignments. It brings through my profiles, long sections as Civil3D profiles. It brings through, this is individual lines that the surface is constructed out of, but there's actually, behind here in grey, that's my surface. What it also brings through, which is quite nice, is there is a boundary line there. So I can simply select my surface, add data from the ribbon, or do it through the prospector, apply boundary, outer boundary, it's non-destructive, and we go and pick that one, and you can see that it's cut that back using the boundary, which is what we want. There's another surface here, which is the design surface, which has got another boundary we can use. In here is another alignment, which is what those big exclamation marks were. It's just this one has tangency breaks in there, so with the 2013 and 2012 tools you can fix up those tangency points as well if they're not quite tangent. I think that one was just sketched initially when it was first made, so it's probably not surprising that it's not tangent. Okay, so essentially that's what it does, and you can reproduce all the surfaces produced in 12D, etc., plus get your profiles and things out, which is nice. The exporter has a very, very similar structure or dialog box to the importer, with what you want to export, string naming options, and other bits and pieces you can name for going the other way. Alright, so really quickly, that's what it does. We should probably look at the Genio version of this, so let me just close this drawing down and start a new one. Now the Genio ImportExport has been in Civil3D for quite a while and hasn't been changed. It's still the same as what was there previously. So let me just rearrange my toolbar here. There we go. Bring up a new drawing, and we'll bring in, it's actually the same project, or very similar, but just using the Genio import function. There we go. That's better. So rather than using a 12D, we can go for a Genio file. If those who are unfamiliar with what it is, it's from MX. So I can expand that out. You can import from a Genio, you can export to a Genio, and you can import from a model file if you want to do that as well from MX. Let's just go import from Genio, just as the example. Very similar to the 12D import dialog box with the way you want to get things to appear. Where are we? Just break lines, Genio surface style. Just put a style on any surfaces that come through, but I think we'll find it may not come through. So here we go. Okay, so let's run with that. Let's open our Genio file. Again, right-click in here, select all models and strings, and go import. It says it's completed, so I can close that dialog box. And often, and there's a case in with this one, this is what you'll get, which is really just the strings. A couple of strings dropping to 0 elevation there. But it's the strings of the model that has been produced. So we've got a bit of a footpath widening going on here. And we've got the strings, if you have a look at this corner, strings of the different pavement depths that are being produced there. If you're wanting surfaces, and often the surfaces won't come through with that Genio import, you really need to make a drawing file of triangles from MX and bring them in to Civil3D. So just an insert command, tell it to explode what we bring in, don't scale, don't rotate, and don't specify an insertion point, and just go grab surface triangles drawing, produce from MX, and that will bring in the triangles obviously, and you can recreate your surface using those triangles. We've actually got these other ones. There's another surface there as well. That's our design surface obviously. Alright, so very quickly, import from Genio, export's very similar to the 12D dialog boxes. They've essentially just duplicated them and made them work with different file types, which keeps it simple. Okay, so that's quickly through those. And they've been there for, well, at least the last two versions. Genio's been there for quite a long time. Okay, next one, 3ds Max. This is a new one here. There's an extension for Civil View, which is the tool for taking your Civil3D drawings out into 3ds Max. So let me just open another drawing here, close this one, open another one, and this is going to be the one called to 3ds DWG. Okay, let's jump in here. Previously, we've had the ability to use this function here, export to Civil View for 3ds Max. It used to be another extension that you loaded on Civil3D. Now it's built in 2013. I think it was built in 2012 as well. We've got a couple of things that we're going to export. One is we've got a corridor in here. We want to export that to 3ds Max. And we've got a surface here, but that surface, if you look carefully, Let's have a look at it. And the object viewer has had a hole cut in it, which that hole has been made with the boundary of the corridor surface, which is another new thing in Civil3D 2013. In fact, you can specify a surface to cut a hole as a hide boundary, and it remains dynamic. So if I move that corridor now, this hole would actually move with it, which is pretty cool. We want to do that in 3ds Max because what it's going to do is put our surface down on the ground. It's going to lay our corridor into that hole, and if we didn't have a hole there and the corridor went below the ground surface would actually cover it up in 3ds Max. Most sorts of visualization software would do the same thing, would actually display both of them in the same area, and so whichever one's on top is the one that gets displayed, or whichever one has a higher elevation. So we cut that hole first to make it fit. So let's go and export those. So this is what you had previously, and this is the standard export to Civil view. Now I did do some webcasts on this last year, I think it was, 2 webcasts. It took you through the whole process and how to build up a project in 3ds Max. This is the first part of it. And what you want to do, you don't want to export everything. So I'm just going to take that corridor, Dean Road corridor, and I only want one surface. I want the 2 3ds surface, which is that one with the hole cut in it. You don't take all the other stuff. It's just you're not going to need it in 3ds Max. It's just for visualization purposes. You just need the top surfaces, and it's only going to take the top bits of the corridor as well. You don't want all the extra information. It's just going to clutter up 3ds Max and slow it down. So we hit the export button, and let's put it in the extensions folder with 2 3ds, and we'll call this base. We'll save it. It makes a VSP 3D file. And we're good to go. You always get these little multiple links bit where you've got a region change, so that's nothing to be too concerned about. Close that, and we can do one more thing, which is the new extension. So if we open that up, and you can see it takes pipe networks and alignments as well to Civil View. So let's double click on that and specify again what we want to take through. Let's take, we've got some miscellaneous alignments and pipe knot alignments, an existing curb alignment, but we've also got a pipe network. So let's leave all of that ticked on. I think you can change the point spacing on the alignments when it turns them into lines in 3ds. But let's just go export on that to 3ds new. That's what I'm going to call it. The VSP 3D file, and save that one in there too. And that's complete, so we can close it. Okay, we've got a little pipe network here. If you have a close look next to our corridor, and it's discharging down here to a little wing wall. Okay, so let's jump over to 3ds Max now. This is it here. The screens catch up. There you go. And we get the Civil View pane button up the top here. If you're using the Infrastructure Design Suite, that Civil View will be there by default. If you're using standard 3ds Max, you need to load that, and it's in the installation files directories. It doesn't load by default. And didn't used to load with a tick box. I'm not sure if they've changed that yet, but if you just Google search where to look for it, it's the easiest way to find it. It'll tell you which folder it's in, and you can load up Civil View into 3ds if it's not there when you start it up. So we're going to go to a geometry import and import a VSP 3D file. Incidentally, you can see this does bring in 12D files, and this is where it was initially seen that you could actually import 12D and 3D files into 3ds Max, and Sean pushed them to say, well, if you can read both of those file formats, surely we can make a translator, and that's where the 12D import-export function came from. But we're going to be reading a VSP3D file into here, the two we've just made, so let's go and see if I can find, here we go, here's my folder. Let's bring in the base first, one we could always do previously, and you just basically want to tell it the things you want to bring in. So there's all my surfaces, top of my corridor, my ground surface, and I think that's all I'm going to bring in this case. Again, minimizing what you're going to bring in. So we go, okay, it's going to translate it, which is what we want, so we go yes, and it's going to not use an interpretation style, so I'll go yes again. Now with the exporter, we actually end up with the corridor itself. Let's change this so we can zoom in and out a bit better. Here we go. The corridor gets some nice texturing put on it. There's gravel there and grass, and if we actually do a render of it, it looks really nice. So that's what we could do before. This checkerboard pattern is what the surfaces in 3ds Max look like before you put an aerial photograph or an image over the top of them. Again, if you want to see how to do that, go jump onto the website, download the 3ds Max webinars. I did. There's 2 of them, part 1 and part 2 from last year, and well, that'll teach you as much as I know about taking stuff through the 3ds Max from Civil3D. Nice thing about it, it's made a little panel here called the Civil View Explorer. Most of what you want to do in Civil3D is actually manipulated from this panel View Explorer, which shortcuts a lot of the things that you might spend months trying to find in 3ds Max. It's a very, very big program. We can produce a nice scene fairly readily and fairly quickly using this toolbar by itself, which is what it's really designed for. So that's what Civil View actually is. However, we want to look at what these extensions give us, so we go and bring in the other VSP3D file that we created, and this is the one from the extension, so it's the new one. Open that. Let's bring through all of that stuff to see what it gives us. You go OK. I'm not going to use interpretation styles, and if we zoom in, just let your screens catch up a bit. There is 2 red lines on the surface of the corridor itself. One is the centerline alignment, and it's actually the profile that it's showing there because it's elevated. And there's also another alignment and profile for an existing edge of curb or edge of road, edge of seal, which is the other one on the left. So those have come through. If we have a look down at 0 elevation, there is the alignment from the pipes. That's at 0 elevation because there's no profile associated with it. However, if we go and have a look underneath the surface and zoom in a bit, you should see that we've got our Civil3D pipes and structures turning up there underneath the surface, and that's what you couldn't do before, so you can bring those through to 3ds Max now if you want to. If we go above the surface, we should see just there's the top of the wing wall sticking through there, and top of one of the manholes as well by the look of it. Yep, sticking through the surface. So that's what it does. That's what the extension does. Brings through your pipes, brings through your alignments and profiles, and then you can use those to construct things in 3ds Max off. Okay. So that's what that one's about. How are we going for time? Halfway. Okay, it's half an hour gone. About on time. So let me close 3ds Max here. Oh, let me just see. If there's any questions at the moment, looks like Pretty good for questions, that's fine. Somebody's saying they've got a wee problem with the audio, so perhaps you might need to, if you can't get that resolved in the next little while, just grab the webinar from the website and view it later. Okay, so let me close 3ds Max, minimize it anyway, and pull up the next bit, which is let's have a look at the cartogramma. That's a new one. I'm not sure if I'm pronouncing it correctly, but that's what I'll call it. So let's, no, I don't want to say changes to that. It's this one here, cartogramma, utility for Civil3D, and there's a few functions involved with it there in the toolbox. So let me go and, let me see. I've just got a drawing here I'm going to open up. Open a little drawing. It's just got 2 surfaces in it, and that's all it should have in it. If anybody's done training with us previously, you'll probably recognize this. There's 2 surfaces intersecting each other. The flatter one is the design surface, so we've got a lot of fill out the front, a lot of cut up the back, and the steeper one is our existing ground surface that we want to compare with it. Alright, so let's close that. To make this work, we first need a polyline that defines the area within which we want to get some volume information out. Down to there. That's not done now. Input should be turned off. Down to there. To there. Let's go back to there and see if it closed. Okay. Let's start this up. So you click on or double click, or you can go right click execute for any of these tools. Create a cartogramma. We're talking about using a ground surface of OGL and a design surface of design. So that's the way it's going to compute what it's going to compute its volumes against. We want to pick a boundary, which is why I drew my polyline, the boundary of the area that's going to consider. So click on there. A mesh origin. So this thing makes a mesh. You'll see when we create it. I'm going to make the origins the lower left-hand corner. Calculation method. Do you want to do square sampling over the surface or use the triangulation? I want to use the triangulation, which I think most people in Australia and New Zealand will. And a square side length of 20 meters should be fine. Just going to draw some hatches. Let's change them so they're slightly different. You can change them to whatever you want, obviously. And we go OK. And this is what it produces. Now, let me just change my stream color here just so it makes it a little bit easier to read. Okay, just zoom in. It's a whole bunch of little squares. Each one has a volume number in the center of it. Let your screens catch up. There, you should be seeing that now. So that is, this square is minus 8,145. So there is 8,145 cubic meters of cut within that square. This is a very big amount of cut and fill. You can see down on the vertexes of each square is the amount of cut and fill. So I've got 23 meters of cut going at that area. The level of one surface and the level of the other surface is shown there as well. Okay, it does that over the entire area that we specified, and where we are in fill, it turns into red, and we've got a different hatch. Now these are all just plain AutoCAD entities, just text and hatches and line work. So you can quite happily copy and paste that out to plain AutoCAD, or just open it in plain AutoCAD. We'll be fine. There's nothing technical about these things. It just does the analysis once and draws these. You've got the zero cut fill line appears in there as well, which is a nice, easy way of getting one of those. But also we can do other things. So we can click on Edit Cartogramma over in the toolbox, pick the one you want to edit, and get back to that same toolbox we used when we created it, and rejig the numbers or the hatches or whatever we want. So that can be changed in there. Split cartogramma cells. So let's zoom in on one of these cells here with 830 cubic meters of cut going on in here. I can draw a polyline through the cell in any sort of way that I want. Let's take it down to this corner and split it. So the way we do that is we run split the cell, select the cartogramma that we're talking about, just that one, specify either a layer for the break lines or select the break lines from the drawing. So effectively it's the line that's going to break that cell, that's what they're talking about, so it's that one. There it is, and go OK. And I'll recalculate just that cell, and we've got -257 in there and -572 in there. So you can split up the cells further if that's going to be something that's going to be useful for you. Obviously this thing is just mtext, so I should be able to move it around the place, which I can. I probably need to move the mask. There should be a mask that comes with it, I think. Yes, there it is. It's a border on the hatch there, a mask on the hatch. So that's some of the functionality. You can simply refresh it if you've changed surfaces, and once again, if you don't want it, you've got the erase button up here, so I simply erase it, pick it out of here, and it's gone. Too easy. Alright, that's what that's about. Interesting little tool. Will be useful for some people. I have had some people, wanting to do that type of thing before. So that's nice that we've got that in there if we're wanting it at some stage. Here's another good one. Corridor solids. We did have this in 2012. Let me just change my screen back again. And no, don't save changes there. We were talking about corridor solids, yes. Let's open another little drawing file that I've got prepared here. Solids model DWG. It's just got a surface and a corridor made on it, similar to the corridor we used previously. Okay, so I'm going to select that one. It's got two regions here currently. Let's just make a third, go split region from up on the ribbon. Pick the region that you want, split that one, and at what station? Let's do it roughly at that station. You can type in the number, and it's just going to split that region again. So we're going to have actually 3 regions along this corridor, just for the hang of it. The reason why I'm doing that is that when we make corridor solids out of this, you'll get a solid for each, or multiple solids for each region. And that will do me. So you can see by the grips on that corridor, we've got 1, 2, 3 regions now. Okay, so this was a download in 2012. It's now part of this, group of utilities now in 2013. So it's this one here, corridor solids for Civil3D. We can extract corridor solids and we can calculate mass properties, which is really just the mass prop command. That's all that is. So let's go and extract corridor solids. Double click on it, or right click and execute. And it brings up this screen. So what we can do, it's a dialog box I should say. What we can do is just select this button down here. You can pick a particular region or regions using that button down the bottom. I'm just going to go add all baseline regions, and I'll bring in all of the components of that corridor. Basically what it's talking about doing is taking the corridor subassemblies, and for each little shape in that subassembly, making a AutoCAD solid out of it. We can go through and change some colors, so let me see if we go through and change. Here's the first region. That's the lane materials, and I'm going to change my pave one to be, what color do I want? Let's make it red. And let's have the base material as being pinky browny color. That'll do. Color number 31. And then I'm going to find the lane on the other side. So that's the lane on the left. Let's go for the lane on the right. Here it is. And do the same thing again. You can, I believe, hold down the, let's try it, Control key and pick multiple ones and change them all in one hit. But I didn't do that, so I'm just going to make this one the same. Red, and that one will be color 31. Okay. And you can do the same thing or different things in each of the regions that you're wanting out, just to highlight those solids. But let's run with that for the moment. We can change obviously as much as we want. Let's go to the output options. We can choose to make AutoCAD solids, or we can make AutoCAD bodies, both based on the corridor sampling, or the straight lines in the corridor, or you can tell it to try and make them more curvy by making them as swept solids. I think we'll just run with the corridor solids because we've got reasonable sampling in there, especially where it starts to curve, so I'm pretty happy with that. We can choose to make these in the current drawing or add them actually to a new drawing. Let's try a new drawing, and I'll put it on my desktop and we'll call it solids model out. Will do. Save it there. Okay, with all that set, we can just simply click the Create Solids button and off she'll go. So let's open up that drawing that we just created, a separate drawing. On the desktop, solids model out. It's just my desktop, so don't worry about that. And zoom extents. Okay, this is what we've got. Let me kick it into a 3D view. And actually I'll go around the corner. It's better. And I'm going to change it from wireframe to a realistic view. Okay, these blue bits are actually the daylight slopes, which are just planar. They don't have any depth and don't have any volume, so I'm not really worried about those particularly much. So I'm just going to freeze that particular layer. What we do want to see is, zoom in on the end of here, here are our corridor solids. So they're all together at the moment. I can pick that one and that one, for instance, and I'll just use the move command and drag it up. So you can see they are actually AutoCAD solid objects. I'll select that, Control 1. It's a 3D solid. Nice thing about a 3D solid is you can select it and use the mass prop command. Actually select it after the fact. Go enter, and you get all sorts of stuff, but mostly the volume just comes straight out. So if you're not wanting to work out the volumes of your corridor chainage by chainage, we're just interested in certain regions one at a time. You can that would be a fast way to bring out the to extract, if you like, the solids without having to do a complete volume extraction in Civil3D, which can be a bit time consuming. But what this is really for is to now be able to take those through to Navisworks. So for those who aren't familiar with Navisworks, it's been used by architects and structural people for a long time, in that you can take different models from for instance, all your ducting, your structural steel work, your architectural walls, bring them all together in Navisworks, make one model out of them and see where they clash and do timelining and how you're going to construct it and how things are going to work around each other as they get constructed. It was a bit of a pain to try and bring a civil model in previously, but with this we can just extract the shapes of the civil model we've constructed and pull them straight out into Navisworks, which makes it easy. And that's really where the power of this comes in. Okay, so that's where we're talking about with the models. We've also got, as you can see here, they all come out into layers. This is lane super elevation right number 4. And let's just move on that one. As you can see, it's duplicating the shape of the corridor properly as it should be. It's just 25mm thick, that particular one. But you've got all your layers underneath. You can have your curves and everything else will be in here too as solids. So that's what that one does, which is pretty cool. We're going to be having actually running some courses shortly, in a little while, regarding taking these types of corridor solids and throwing them actually into Navisworks, which is part of the start. Well, it's not the start. It's the way of incorporating now your civil models into the whole BIM building information model process, which is nice to have that ability now to work with other people with their own models and work in the Civil3D model as well. Okay, last one to look at in the last few minutes, borehole logging. Oh, just another question. So how will we do that? Import a 12D road to Navisworks, including 12D drainage. I haven't tried the 12D drainage, but you can certainly, or you could use the 12D tool to import your 12D model into Civil3D. You can then reproduce the corridor. We don't actually get the corridor from 12D, but we can certainly reproduce it using string lines as a Civil3D model, then take it into Navisworks. So that's how we do that. Just as a question that was asked there. Same with MX if you needed to construct your civil model off your string lines from MX and then take it into Navisworks. That's one of the things that we're going to be looking at in the upcoming training as well. Okay, so last one, the boreholes tool. This is actually quite a neat little one, actually. So let's go and have a try at that. Close that one as well. Open up, where is it? Open up, extensions. Borehole surface, that's the one. This is actually the data set that comes with the borehole tool for you to play around and have a go with. So you'll get this if you download it. So it's just got a surface here, and it's just a plain surface that I built from the data. This borehole utility opens up, well, it actually opens up a number of different file types for boreholes. One is a CSV. So we're going to go and do that. So let's go and bring in, oh no, let's actually go and have a look at what that is first. So in here under the desktop, under webinars, extensions, and let's go and build sorry, not going to try and build it here. Here we go, here's the sample data. Let's go and have a look at the CSV file. This is the type of file it's looking for. It's got a borehole number at the beginning. It's got the X and Y coordinates of that borehole, and then it's got a depth of a particular material, goes from 0 to -13. This is in centimetres. You can see the file in centimetres. This comes from the UK. It looks like the borehole logs that they get are always in centimetres, from what I can tell. So it is expecting that file to be in centimetres. Use Excel to change it if it's not. So each of these boreholes has, I think, 4 different layers in it, each represented by a different line, and the depth to the top and bottom of each of those layers and the name of each of those layers. So that's what we're actually opening up. So let's go and have a look at the importer. And there's a path to the folder where that file is, or if you've got multiple files, they'll all show in here, and you just select the ones you want. It's going to make Civil3D points out of them effectively first. That's the first thing it's going to do. So we tell it to use a surface which exists in ground to give the level of the top of the borehole. You can change that. There's a settings tab here. It's going to derive the elevations from the data. Sometimes if the surface elevation is part of the file, you won't need to do that. You won't need to derive it. It'll use the elevation out of the file, in which case you just don't derive. We'll talk about the rest of this later on. I think there's just the different labels you can get it to make. But that's all fairly self-inflammatory, I think. And it's going to create point groups, and you'll see that happen as we do it. So we go to import. That should be all we need, I think. So we go import. All files processed successfully, so we can close it. And what it's done, it's made some Civil3D points in here. Now it's just using the standard style to begin with. You can change that, because what it's actually, well, let me go and change this standard style first, and we can have a look at what it's actually done once we've done that. So I'm just going to change it so that in the standard style, when we put it in model display, we can actually see the points. So if I select those points, go into the object viewer, give it a bit of a rotate, you can see it's actually made a Civil3D point, if you look carefully, for each of the interfaces between those layers from the boreholes as it goes down below the surface of the ground. So it's one point for the top, one for the bottom of the first layer, one for the bottom of the second layer, one for the bottom of the third layer. 1, 2, 3, 3 or 4 layers. 4 layers I thought there was. 1, 2, 3. I see 3. We'll see when we make the boreholes anyway. Okay, so that's what it's actually done, made some Civil3D points from that particular type of file. And there's about 4 different file formats it can read, which are, from the UK at least, the common borehole logs that they get. We'll have to see how applicable that is to what you guys get on a regular basis. However, the next thing we want to do is make a profile. So I'm just going to draw an alignment first. It doesn't matter what I call it at the moment. Don't want any design criteria. Okay, and I'm going to sketch it in to go from, say, oops, just do straight lines. It doesn't have to be, obviously, somewhere through here. It doesn't have to be straight through your points. I'm going to actually do it down beside my points and get it to project them onto that alignment. So that's my alignment. I'm going to pick my alignment and make a profile view out of it. Just from the launch pad up here, surface profile. Add in the EG surface, draw and profile view. I'm just going to accept all the defaults for this and pop it over there. So there's my profile. Okay, once we've done that, we can run the importer again, Borehole importer, and give it the path to the input files again. Tick it on. In the settings tab, it's got one here, maximum distance of borehole to alignment. So it's going to look for all the boreholes within 20 meters either side of that alignment. So in this particular case, in the background here, it should ignore this one off to the north. It should, we'll find out in a minute. Okay, here's my utility. And it's going to make the boreholes 2% of the length of the profile view. That's fine. These are the labels it's going to use, but I'll just tick on those 4. Will be fine for now. That being done, I don't want to create any more Civil3D points, so I don't tell it to do that. I need to specify the EG surface as the surface, and I can click on Project Boreholes in Profile View, and that's the profile view I want to put it in. Hit the Import button. says it's all done successfully, and this is what it will have done. I thought it was 4 layers. Okay, so it's put in, these are blocks. Each one's a block for where the borehole is, and it's projected to that alignment, which is why the block may not necessarily line up completely with the surface level, because it's obviously behind or in front of the actual long section that I've drawn. It's labeling them up, and it's also putting the depths to the interface of each one. You may find that if you've got very thin layers, the text will tend to overwrite itself a bit. Again, this is just AutoCAD text. So I can explode that block, I can select that, and just move it to where I want it, and clean it up if we've got very thin layers. These things, there's an actual shape that's derived here for each one. Again, it's just an AutoCAD entity, it's a polygon or a rectangle. Where those actually come from, well, let me show you first of all. Just probably get too carried away. Back in the prospector, it actually makes a point group for each of those different layers. One for the silt, one for the clay, one for the gravel, one for the topsoil, and one for all the boreholes. So it does that by default when it puts those points into your drawing, so it's very easy to just make a surface out of any one of those, and you get the clay surface, for instance, or the clay interface surface. What it also does, if you go to the Settings tab and the Styles, under General, Multi-Purpose Styles, and Shape Styles, it'll put in a shape style for each one of those. So if we go to, for instance, the clay, that's new. It put it in there as it needed to for each one of those layers. If I go and edit that, in the Display tab, I can change the view direction to profile because it's drawing itself in a profile, and I can turn on the border and a fill. I can choose a fill. We'll just take a solid fill for now, but let's change its color to being, I don't know, some sort of yellow. And let's put a border on it that's green just for the heck of it. And go OK. Now I won't change it yet because those things are only processed when you bring them in, and then they're AutoCAD entities, non-dynamic. So you just select them and delete them and just rerun the Borehole importer again. Select your path, select your file, select your ground, tell it to put it into a profile view, import. So there you go, it's got a hatch pattern applied in there. It's actually part of a block at the moment, you explode it. It'll be a hatch pattern. Now if you're using these things all the time, you simply have those, rather than getting the software to make those styles, those multi-purpose styles, the shape styles every time. If you have those pre-existing in your template, obviously when it comes through and it finds the clay layer, it'll see there's already a style for that, so it won't need to make one, and it will grab the colors that you've told it to use. So that's quite actually neat and dandy. I've had a lot of people sort of querying whether we can actually do that sort of thing in Civil3D, and that's what this tool's for. It's been developed by guys in the UK. There's good explanations, and it's actually a little video that comes with this particular tool as well when you load it up. So essentially that's the end of where we really wanted to get through to. If you change the profile view vertical scale on this thing here, it's actually attaching these things to the surface. So wherever the surface is, they'll stay where they're put. If you change it after you've put them in here, you would need to either run the tool again or drag them down vertically. They're non-dynamic, as I said. They are just simply AutoCAD entities, and it's done that way so that you can use these things in AutoCAD without any problems. Translate it back to AutoCAD if need be. Okay. I think that's about where we wanted to get to, just searching through the questions here. I think there's just one here that says, can you show the points in the tool space so we can see how they are arranged in point groups? Okay, where's the point groups? Back up in here in the prospector. Here's the clay. There's your points that are in the point group for clay, for instance. And if we wanted to make a surface out of that, we simply make a surface and tell it to make itself out of that particular point group, and you get your clay surface. Obviously just straight lining between each of the boreholes. Okay. And one more just before we go. Are these part of standard 3D 2013? I presume you're meaning, are these point groups part of it? No, they're not. If you don't have those pre-existing with those particular names, which correspond to the names out of the borehole log, it creates those for you. So the actual software, the borehole importer, creates those when you bring your borehole points in, which is quite nice.